Welcome to Chapter 8. This is going to give you a little bit of a break from the factoring that we've done in Chapter 7 and go into something a little different, something that you would have done in Math 90, at least to some extent. We're going to take that out and do a little further. But we'll first do a little bit of review in Section 8.1. And Section 8.1 covers graphical solutions of compound inequalities. So this is graphical solutions in compound inequalities. So when we're looking for the solutions to inequalities in general, there are several ways of calculating these solutions. Well, not several ways of calculating them necessarily. The ways that they're usually done are pretty consistent, but there are several ways of representing the solutions. And that's what we're going to take a particular interest in showing here. So we're going to take a look, and we're going to be looking at some of the problems that are be later in the book. So what we're going to study first is how we can represent a solution to something on a number line and how we could represent it in interval notation. So let's start off with just a simple example of how we represent the solution to something on a number line and then how we represent that solution in interval notation. So first, let's go ahead and we'll start with something like x is less than 3. So if we want to take something like this is something we've solved. This would be something we would have at the end of an equation that might have to be solved. So what we're looking at right now is kind of the end product, and then how do we represent this on a number line? So putting it on a number line, I'm going to do a couple things here. Feel free to stop the video at any time and listen to exactly what's going on. First, we're going to go ahead and we're going to draw a number line. We're going to make a tick and we're going to put this at 3. So the first step is just identifying the point that comes from what would be the solution to the inequality and placing that value on the number line. The next thing that we need to decide is, because this is less than or greater than, we are going to use a set of parentheses on this. So in the case that it was less than or equal to or greater than or equal to, we would use brackets. So we're going to decide that we're going to use parentheses on this, but here's how this is going to go. So we need to decide which way this line is going to go. So we're looking for values that are less than 3. Well, values that are less than 3 include, let's say, 2, 1, 0, and going all the way to negative infinity. So one thing we could do here is from the value of 3, we can draw an arrow going the direction toward negative infinity. So another trick for this is we can actually use the inequality as long as the variable is on the left. This is an important detail. As long as the variable is on the left, we can use the direction of the inequality from here to decide which way the arrow is going to go. And because I'm using an open like parenthesis, I'm going to put the value of 3 here. So the reason we use this instead of a bracket is because x cannot be equal to 3. It kind of gets really close to 3, but never quite gets to 3. So it goes from like 3 all the way down to negative infinity. So given that we draw out the number 3, we draw an arrow, and we draw the parenthesis, we now have the main features of writing the solution of this as a number line. So what we're going to do next is express the solution another way using what's called interval notation. So with interval notation, we write all of the possible values more concisely than a number line, and something that's fairly simple. So this parenthesis here, I'm going to use here, and we know that the numbers can go up to 3, but not go to 3. But let's say here, this is going to go all the way down to negative infinity. So I'm going to put negative infinity here. And one key idea about negative infinity is when I go to negative infinity or positive infinity, I always use a parenthesis because we never get to infinity. We just never get there. You can't quite get to infinity and then have somewhere else to go. You never get to infinity. So we're going to take a look at another example here before we go to the compound inequality, and let's see how we represent it. So we're going to start off with something as x is greater than or equal to negative 5. So we now want to go ahead and put this on a number line. So I'm going to first start by drawing a number line. And I'll put a tick here. I'm just going to put negative 5 here. So we're looking for all the values greater than negative 5. Well, 0 is greater than negative 5, so it's 1, 2, 3. So we're drawing an arrow in this direction. Note that the variables to the left, the inequality points to the right, so we draw our arrow here. Because this is a greater than or equal to, we're now going to go ahead and put a bracket, which is different than what we showed above where we used a parenthesis. So the main difference here is because this is less than only, we use a parenthesis as we indicate here. Because this is greater than or equal to, we use a bracket as shown here. So this is a representation of the solution. X is greater than or equal to negative 5 shown on a number line. What does this look like now in interval notation? Well, in interval notation now, we're going to start off with a bracket because this number can go all the way down to negative 5. Negative 5 can be a solution. That's because negative 5 is not greater than, but it is in fact equal to negative 5. And this is going to go all the way and keep going all the way to positive infinity. And as I mentioned above, we're going to use a parenthesis to represent the value of positive infinity. So when we're looking at solving inequalities or compound inequalities, we can express the solution in 3 ways. One, we can express it using the inequality itself. We can express the solution to the inequality on a number line, and we can express the inequality in interval notation. You have to be familiar and comfortable using all 3. So now that we've taken a look at how to write answers in 3 different notations, we're going to go ahead and we're going to begin with some problems in the book. This is going to be question 47. And this is going to be writing in interval notation the following. 3 is less than x, which is less than 7. So what we're first going to do is we're going to go ahead and to put this representation on a number line. Essentially, what is happening here is that x is between the value of 3 and 7. So x is between the value of 3 and 7. So we're going to put the value of 3 here, and we're going to put the value of 7 here. So since we're dealing with less than only symbols, we're going to be using the parentheses here. Okay, and we're going to go ahead and draw a line like so. So we're representing the solution's for x on a number line here. For example, we could say 3 is less than 4, and 4 is less than 7. 4, 5, 6, these are all values in between 3 and 7, and that would work. 3 is less than 5, and 5 is less than 7. Those values also work. So here we've written we've expressed the answer of this, or we've expressed this relationship on a number line. We can also express this relationship in interval notation. Oftentimes I recommend that if you have an answer like this, that you may want to put it in a number line before expressing it in interval notation, because the way you get interval notation works quite nicely. So if I want to represent the value of x as being between 3 and 7, but not equal to 3 or 7, all I do is I take the values of the parentheses here, going from 3 to 7 here, and now I've expressed the values of possible values of x in interval notation. So my interval is between 3 and 7, but not including 3 and 7. So let's go ahead and take a look at another example for further clarification. So we're going to go ahead and take a look at number 49. So now we've got the solution. X is, excuse me, not x, I apologize for that. Negative 6 is less than or equal to y, which is less than or equal to 0. So again, we're going to go ahead and express this first on a number line. And I'm going to put the values of negative 6 and 0 on that number line. Basically, the value of y is located between negative 6 and 0. And because they can be equal to, I can go ahead and I can bracket these off in the following way and just draw my line in between. So I've now effectively graphed the solution to this as being between negative 6 and 0, including the values of negative 6 and 0. Now, very similarly to the question that we did up here, if I want to write this answer in interval notation, I'm going to not use the parentheses, but I will use the brackets this time. I'm going to put the values of 6 and 0 in, and now I have my solution in interval notation. So here's a solution you may obtain when working with this algebraically. Here's a solution you express with us on a number line, and here is the solution that's expressed in interval notation. So feel free to stop the video at any time to make a note of this, because whether we express a solution as something we obtained algebraically, we express that solution on a number line, or we express a solution with interval notation, you have to be familiar and comfortable with all three. You may be asked for any three of these representations on any given test or quiz. Let's go ahead and go forward, and let's see some problems now that we actually have to work through. Actually, no, I'm going to take that back. We're going to take a look at one other type of question that's going to be in 53 and see how we represent something like this. So you may see another problem written in the following way. Actually, we'll look at two more. 53 will be x is less than or equal to negative 2, or x is greater than 1. So really what we have is what is known as compound inequalities. And the last two examples that we showed over there was one example of a compound inequality. Here is one possible solution that you might obtain when you're trying to solve compound inequalities. So let's take a look at how we do this. Excuse me. So here what I'm going to do is I'm going to graph each of these if they were separate, but I'm going to graph them on the same number line. For example, let's go ahead and start with negative 2. I know that this is going to go to the left, and I know because it's less than or equal to, it's going to be a block or a bracket. Now for x is greater than 1, I'm going to put a line at 1. I'm going to draw my arrow because this is pointing to the right. I'm going to draw my arrow this way, and I'm going to draw a parenthesis as such. So the way we represent this solution in interval notation is a little different. So we have a solution you might obtain by working out a problem. We have a solution written on a number line. What does this look like in interval notation? Well, really there's going to be two parts to this interval notation. The first part is going to go from negative infinity, as this goes toward, all the way, bracket, to negative 2. So underneath the number line, we can put the interval notation for this part. The next part here, we go from 1, using a parenthesis because of this, and because of the greater than only symbol, and we use parenthesis here, we use a parenthesis here. This is going to go all the way to positive infinity, and we put that here. Finally, we have here these two being joined together as being part of the problem. So what we have as a solution, the way we express this, is because these are both part of the solution, is we write these as I like to call this, the union of these two. So between these two, we're going to put a U for union. And our final answer in the notation will look like this, but let me go ahead and write that again. From negative infinity to negative 2, bracket, the union of 1 and infinity. And this will be the final answer expressed in interval notation. So there is no one value that can make both of these true because these don't overlap at all. So it either has to make this part true or it has to make this part true. Let's go ahead and take a look at one that involves an and that's going to be number 55. So we have the values of x is greater than negative 2 and x is less than 4. So because we're looking at we're looking at values that don't satisfy one or the other only. We're looking for values of x that satisfy both conditions. So what we're going to do here is we're going to go ahead and put this on a number line, and let's see what this looks like. So I start with negative 2 here. That is going to go to the right, so I'm going to just draw my parenthesis here because it's a greater than symbol only. Draw my arrow going this way, and I wait. I put my 4 here. I know this is pointing to the left because I'm looking for values less than 4. Parenthesis going to the right. These two join in the middle. So it's going to be the area between negative 2 and 4. So I now have expressed the relationship of x, or the values of x, that are both greater than negative 2 and are less than 4. And these values are here. So you could say, for example, 0 is in this interval. 0 is greater than negative 2, and 0 is less than 4. So 0 is one example of a number that fits both of these conditions. It makes this true, and it makes this true. How do we express this in interval notation? Well, very much like the way we did from the number line in a previous example. Go here to here is between negative 2 and 4. And now we have our answer expressed using interval notation. So you will be given several examples of this for your consideration in the book to work through, and we'll see how you do with those. Let's go ahead and actually solve and then graph and then write these answers in interval notation. Pay close attention to how you need to express your answer, and let's take a look at how we solve some of these equations. So we'll start with a few that aren't terribly difficult. Let's take a look at 69. So we're going to have negative 2 is less than t plus 1, which is less than 8. So we have something a little different here. We do have a compound inequality, and we have a t plus 1. Basically what's going to happen in a question like this is we have what's in the center here kind of dictating what happens to each of these parts. Well, I don't want t plus 1. I want just t. So I'm going to go ahead and I'm going to subtract 1 from here. But if I take 1 from here, I need to take 1 from here, and I need to take 1 from here. Watch your signage. So, negative 2 minus 1, negative 3. Plus 1, negative 1, these reduce, give me t. 8 minus 1 will give me 7. So now I've actually taken some type of compound inequality, and I have found some type of algebraic solution to this. However, pay attention to how you have to express the solution, and sometimes this may be acceptable as is, but typically you're going to be asked to put this on a number line or write it in interval notation. So let's take a look. Because I have the value of t between negative 3 and positive 7, I'm going to go ahead and put the values of negative 3 and positive 7 on a number line. Because these are less than only, I'm going to go ahead and put these here and just draw my line in between. So now I have that expressed on a number line. So for example, negative 3 is less than 0, but 0 is also less than 7, and 0 will certainly follow the interval. So how do we write this in interval notation now? Well, we have the parentheses we use from above because of the less than only symbols. Take the negative 3 that's here, the 7 that's here, put a comma in between, and now we have our solution expressed in interval notation. So let's go ahead and take a look at another example similar to this, but something that maybe perhaps be a little more challenging. We're going to go ahead and take a look at 77. So for 77, we have negative 7 is less than or equal to 4x plus 5, which is less than or equal to 13. So this one's going to involve a few steps now. So what we're going to do first, again, what happens in this question is going to be dictated by what is in the middle. So I'm going to go ahead and subtract 5, subtract 5, subtract 5, and that's going to give me negative 12 is less than or equal to 4x, which is less than or equal to 8. Now again, what happens through the rest of this problem is dictated in the middle. I will go ahead and I'm going to divide by 4, divide by 4, divide by 4. This is going to give me negative 3 is less than x, which is less than 2. And now we have an x, once again, sandwiched in the middle. So I'm going to take this algebraic solution I've obtained for the compound inequality, and I'm going to go ahead and write this out on a number line, again using parentheses going in between. And then from the number line, I'm going to go ahead and get the solution. Oops, be careful, because of these, I just caught myself in a mistake here. Because these can be less than or equal to, I'm not going to use a parenthesis, I will use a bracket. So now I'm going to put a bracket here, but I'm also going to write a bracket for my interval notation. So if you were looking to catch me in a mistake, don't worry, I caught myself. So here we start off with a compound inequality problem. I subtract from all three parts of it. I divide by into all three parts of it. I get my initial solution, express that solution on a number line, and then write it in interval notation. You don't always have to write it in interval notation, but I'm taking this and reinforcing this concept. Let's go ahead and take a look at a few more questions before wrapping up the lesson for section 8.1. So we have another question in the form 71, and here we go. This is going to be 4 is less than x plus 4, and x minus 1 is less than 3. Okay, so let's take a look to see how these problems are simplified, and we'll see what we do from here. Well, I'm going to try to get x by itself, so I'm going to go ahead and subtract 4 from both sides. So when I do that, that's going to give me 0 is less than x. Over here, I'm going to do my work completely separate. This is two parts to the problem, so let's go ahead and do that. So I'm going to have x is less than 4. So right now I have 0 is less than x, and I have x is less than 4. However, if you recall, I mentioned earlier that you should always try to have the variable on the left to kind of use the rule. And typically when we express our answers to this, we usually express it with the variable on the left. So if you take a look at the value of 0 being less than x, another way we can represent that is that x is greater than 0. So what I'm going to do is I'm going to switch this around. But this is an important idea. If I move the x to the left and I move the 0 to the right, I have to switch the direction of the inequality. So when I switch the x and the 0, I also have to switch the inequality. This is a really key idea. So we're looking at two parts here. We're looking at x is greater than 0 and x is less than 4. So we're going to bring these two together onto a number line. Here's 0, here's 4. It has to be greater than 0 and it has to be less than 4. So the value of x that makes both of these, this and that, true, is going to be between 0 and 4, but not including 0 and 4. So we have now taken these values and put them on our number line. To kind of test this, if you want to see if it works, I can take a number like 2, for example. And I can say, well, 2 is greater than 0, so that would work. But 2 is also less than 4. So we've gotten this correct. And the number must satisfy both conditions. So we've now expressed the solution to this on a number line. If we want to put this in interval notation again, we're going to use the parentheses we obtained here, 0, 4, comma, and we are now done. Let's take a look at an OR problem, and that will conclude our lesson. So we're going to take a look at a problem. This will be kind of a little work. So let's go ahead and start with one new page, and then we'll conclude the lesson for this evening. This is going to be 74, and this is going to be negative 4 is less than or equal to 3n plus 5, or 2n minus 3 is less than or equal to 7. So this is really two problems put into one, which is why we call this a compound inequality. So we're going to go ahead and try to get each variable by itself, much like we do with regular problems. So we're going to subtract 5 from both sides. That's going to be negative 9 is less than or equal to 3n. If I divide both sides by 3, I get negative 3 is less than or equal to n. But remember, if I'm going to switch this around, so I put the variable on the left. So when I move the variable here, I move the negative 3 here, I have to switch the inequality. So now I have n is greater than or equal to negative 3. Let's see what we obtain on this side. So we have on this one, I'm going to go ahead and add 3. I'm going to add 3. So I'm going to have 2n is going to be less than or equal to 10. And if I divide by 2, I'm going to have n is less than or equal to 5. So right now, I have n is greater than or equal to negative 3, or I have n is less than 5. So let's go ahead and see what result we get for this here, and let's go forward. So we're going to go ahead and put this on a number line. So we have negative 3 over here. We have 5 over here. So we're going to graph these. So we have n is greater than or equal to negative 3. So we're going to put a bracket here, drawing our arrow this way, or n is less than or equal to 5. I'm going to put our number line here. We're going to draw the arrow going this way. So what we see here is we have some answers. These are overlapping, and they're going to go like this, and they're going to go like this. So the solution to this is a little interesting. So we find that there are some values that make one true, or other values that make the other one true, but we have some values that also make both of them true. So basically, any value that we put on this number line is going to make at least one of them true, which essentially means that if we have something like this, that the arrows are going to go all the way from negative infinity to infinity. So when we write this and we notice something like this, we're going to go ahead and we're going to write our solution as being negative infinity to infinity. So this is one of those rare exceptions when we put something in interval notation. We may have to do it a little differently. But what we can show here is that this arrow is going to keep going this way, and this one's going to go this way, because we're not looking for it to satisfy both conditions, only one of them. So this is just a little bit of a unique example of this property here. So that concludes our lesson for this. We will see plenty more examples on your homework, and we'll see more examples of this in class. Thank you.